Honors Algebra 1, 8th period, no, 7th period. Today's March 18th, 2020. Okay. And today we're just going to have a quick little video about typical quadratic graphs. We know that quadratics are always have the shape of a parabola, that U shape. And we know a lot about quadratics already. We know factored form, we know standard form, we know how to find the axis of symmetry, how to find vertex, how to find y-intercepts, how to find x-intercepts, how to find all this stuff. The tricky part is getting those 5 points. Okay, we need 5 points to graph. So this is kind of a shortcut for instead of just plugging numbers in. Okay. Because sometimes you'll just have a vertex, and your vertex is going to be far from your y-intercept, and it's kind of annoying to just plug in points and then plug in x values, get y values out. So there are a couple of shortcuts that happen on typical graphs, okay. And it all is kind of dependent on what the a value is. For y equals x squared, or when a equals 1. Okay. Now the x squared part is the part that drives the shape of the quadratic. Okay. The bx, the c, if there is one, they don't really do a whole lot to the placement of the graph. Okay. So if you know you have an a value of 1, and you know what the vertex is, it doesn't matter where the vertex is, it could be anywhere on the graph. But from the vertex, all the points are going to fall into the same pattern. Okay, and it all has to do with what your x values are and what happens to them to get the y values. So from the vertex, every graph of a equals 1 is going to have a point that's over 1 and up 1. So over 1, you could go left 1 or right 1, and then up 1. Okay. If you go over 2 spots from the vertex, your graph is going to move. There's going to be a point that's 4 units up. Okay. Because if you move over 2, 2 squared is 4. And then finally, if you go 3 spots from the vertex, there's going to be a point that's 9 places above that. Over 3 up. 9 because 3 squared is 9. So let's do an example to kind of run that by. We're going to graph a parabola. With a vertex at, let's say, 4, -3. And an a value of 1. So that's all the information we're given. We know the vertex and we know the a value. So how can we find more points? Well, again, it's going to be using that pattern. So we'll start by graphing the vertex. Oops. 4, -3. Over 4, down 3. Now again, since I have an a value of 1, anytime there's an a value of 1, it's always going to have these patterns. From the vertex, you could go over 1, up 1. There's always going to be a point there. You could go over 2, up 4. There's always going to be a point there. And over 3, up 9. There's always going to be a point there. Okay. And then, like, of course, we could always reflect these points over the axis of symmetry. And that's it. There's nothing to plug in. It's just always going to follow that pattern. So again, over 1, up 1, over 2, up 4, and over 3, up 9. So that's just a shortcut of, plugging in. So any A value, anytime A is 1, it's always going to be over 1, up 1, over 2, up 4, over 3, up 9. Now, of course, that up could, if the parabola is opening down, those ups are going to turn into downs. Over 1, down 1, over 2, down 4, over 3, down 9. So that's if A is -1. Okay, well, there's a couple other common ones that we'll see a lot. For y equals 2x squared, okay, meaning your A value is 2. Okay. The same patterns are going to happen, okay, except this time we're going to multiply all those squared values by 2. So from the vertex, you go over 1 on the x-axis, or on the x direction. So if you plug in 1 for x, you'd have 1 squared times 2, which means the next point would be up 2. And you could go over 2 from the vertex, and you're going to guaranteed to have a point at, well, you plug in 2 for x, 2 squared is 4 times 2, it's going to be up 8. If you go over 3, there's going to be a point that is up 18. Okay, plug in 3 for x, 3 squared is 9, 9 times 2 is 18. Okay. So those go up a lot quicker. In a little, in a couple, well, probably after spring break, we're going to talk about the narrowing and the widening of graphs. But if you have an A value of 2, your graph is going to be more narrow than the parent function. So it's going to be a skinnier parabola. All right, and then what if we have a fraction? What if we have a number smaller than 1? So say we have 1/2 x squared, meaning our A value is 1/2. Well, again, from the vertex, I'm just going to copy this. From the vertex, we go over 1. This one's only going to go up 1/2. If you go over 2, if you plug in 2 for x, you're going to go up 2. Okay. 2 squared is 4, half of that is 2. If you go over 3, Three squared is 9. Half of that is 4.5. So that's not really a point you'd want to pick. So instead, we usually go over 4. And that would take you up 8. Let's do another example. Let's do the same one we had before. Whoops, wrong tool. But we're going to change the A value. Let's say we have an A value of 2 this time. All right, so we'll graph this. Oops. We know the vertex is still 4, -3. And now we have an A value of 2. So instead of going over 1, up 1, it's going to go over 1, up 2. And instead of over 2, up 4, it's going to be over 2, up 8. And then, of course, reflect those. All right, so that's the graph. But is there anything else we could find? Because remember, we were only given a B value. We weren't given we were only given an A value. We weren't given an equation or anything. But can we write an equation? And we actually can. So because there are some things we know about this graph. For example, we know the axis of symmetry. The axis of symmetry is going through the vertex. So the axis of symmetry is x equals 4. We also know how to find the axis of symmetry if we were given it in standard form. The axis of symmetry is always the opposite of B over 2 times A. Now, if you look at that formula, we actually know a lot of this information. We know 2 of the 3 variables. We know the axis of symmetry is 4. We just said that. We don't know what B is, but we do know what A is. So we could solve for B. If you solve for B, I'll show all the steps. It's really it's 4 over negative B over 4. Solve for B, multiply 4 on both sides. We'll multiply -4 on both sides to get rid of the negative. And you're left with B equaling -16. We could also figure out what C is. C is always the y-intercept, right? So if we're going from the vertex, the y-intercept is going to be, change colors. It's going to be 1, 2, 3, 4 spots to the left. Okay. And if you have an A value of 2, and you need to go over 4 spots to the left, you would just have to figure out what you're going up. So this would be 2 times 4 squared, which is 32. So from the vertex, we'd have to go over 4 up 32. Okay. Now up 32 is going to be way off my graph. However, I do know that I am at -3 here. I wrote 36. It should be 32. I'm at -3 because that's where the vertex is on the y-axis. y value. So if I add -3 plus 32, it's going to give me a c value of 29. And then once you know a, b, and c, you could write that as an equation in standard form. So that equation of the graph, even though we were only given an a value and a vertex, we were able to find the equation. It's going to be 2x squared minus 16x plus 29. Okay. We'll just do one more graph. Say we have a vertex of 3, 5. And an a value of -1/2. We're going to graph that. Oops. Okay. Again, we're not given a lot of information, but we do know the vertex. We can graph the vertex over 3 up 5. And then follow the pattern that we had. The patterns for 1/2 was over 1 up 1/2, over 2 up 2. I'm going to just pick the whole number as one, so I'm going to do over 2 up 2 and over 4 up 8. But notice that a is negative. So instead of going up, we're going to be going down. So we're going to go over 2, up 2, over 2, down 2. And reflect it. And then over 4, down 8. And again, it's a much quicker way. Even if we were given the full equation, just using these patterns is going to be easier than, plugging in a bunch of numbers. So again, that's just a shortcut. If you like plugging in numbers, that's fine. You can plug in numbers if you're given the equation. But again, you won't always be given the equation. All right, and that's it for today. The homework's going to be on graphing some problems like this, some problems like we've already done. All right, have a great Wednesday.